Hello, everyone. My name is Alex. I've been working as engineering lead in the company named Stan. Stan is a company building the next-gen capital platform. That's a nice name. We just did it together with ChatGPT, next-gen capital. And today I'm going to talk about architecture of Fintech startup and how we're tackling growing complexity at scale. I will not be talking about how we're configuring our Kubernetes, how we're using Helm or Terraform. I will be mainly focused on conceptual problems and some solutions and how we're just simplifying our system. Okay, so let's start. Just quick agenda. I will looking into what is Fintech startup and what is quality attributes, what are the key enemy of scale, its complexity, some tips and solutions about evolutionary architecture and how it helps us to reduce the complexity, and also some practices about everyday SRE we are having in our system, in our company. So first of all, quickly about Fintech startup and quality attributes. Nothing complicated. Fintech startup is a kind of young company which uses digital technologies to improve how financial services work. And we have a lot of examples. This is mainly UK, but in the world there are many other things like payments and money transfer, neobanks, cryptocurrency, alternate lending where Stan is located right now, and some digital banking solutions like Airwallex, Clearbank, and many other things. And for Fintech startup, unfortunately, or just a complication we have anyway, we have a lot of regulations like PCI DSS, cross-border compliance. I don't know all of these things. I'm just hearing this stuff from legal sometimes, but we have to do something for that. And we have to follow some of them, of course, otherwise our company or any other companies in Fintech landscape can be closed or license can be taken back. So we have to do something with that. And just talking about operations and technology excellence in startups, usually there is not a lot of legacy code base, not enough resources to build everything very configurable. Tomorrow is unknown. We don't know the value proposition. This is changing all the time. Depends on situation, but it's changing. So not always we have major processes in such companies in the early stages. RPC and TPS is quite wide in the Fintech sector. And we have a lot of integrations usually because we cannot build everything from scratch on our site, and we need to do a lot of integrations, and some of them stable, some of them not very stable, and many other things to be honest. And just looking at how to achieve exact behavior for our customers, for our system, we want to define the quality. And I'm defining the quality with 5 pillars, but to be honest, it can be possible to do in many other things. But what is quality in that perspective? It's the degree of which our product meets requirements and needs of its users. They have users, we want to satisfy their requirements, and that way we're solving the problem for them. That's our value proposition. And just quickly talking about quality attributes, I'm defining it as 5 things: reliability, security, scalability, performance, and maintainability. And today, because that's part of SRE stuff, I'll be going to talk mainly about maintainability and how we're managing that. But if you're just trying to measure all of that stuff, we can define many metrics for all of them. And depends on the situation, we also need to define some ranges, how much exactly we need to achieve in the specific dimension, like scalability, for instance, or reliability, like mean time before failures, and so on and so forth. And also we have a lot of other attributes, but that's the mainly important things on the top of all of that, which is important. And just key enemy of scale, that's complexity. And just if quickly take a look on the complexity side. So in systems theory, complexity describes how many components in the system are communicating with each other, how many dependencies we have. And system theory helps us to define that in the way we have about, for instance, 4 main principles like systems thinking as a holism. We're looking on the system as a whole thing, feedback loop to get the data and understanding how a system performs, goal-oriented design, and hierarchy in that way. And just looking on the systems engineering, technically this is a field as part of systems theory, but mainly applied to what we're doing in companies like Fintech. It also focuses on how to design, integrate, and manage complex systems over their life cycle. And just looking at the complexity from different types, we can try to use the thing, so essential and accidental complexity, which was introduced by Fred Brooks in his essay No Silver Bullet, which is saying that essential complexity refers to the difficulty of the problem being solved, and they have many examples like nature of distributed systems, KYC, AML, all of the stuff I just discussed, reliable and consistent transaction processing, and many other things just related to the problem we're just solving. And another part, which is produced by us, by developers, by engineers, by architects, is accidental complexity, is part of tools and things we just did together. And it's extra complexity for us, introduced by us, and we have to do something with that to simplify that overhead, because it will make our life much more complicated. And just some examples, like overcomplicated technology stack, excessive microservices breakdown. So many things related to, we have so many abstractions, we don't know how to evolve that. Premature optimization, this is the root of evil, and many other things, to be honest. And just looking at the solution for all of that, we're starting to defining something like evolutionary architecture, how to deal with the complexity. And few things related to that, first of all. So architecture is about the all important stuff, whatever it is. So this is a phrase from architect Alex Johnson. But unfortunately, that's not very useful how to take this phrase and just apply it to the system. We have to look on the architecture from different standpoints, and we can try to, for instance, using that breakdown. So first of all, I would say that architecture is a complexity management for us. So it helps us to structure and controlling dependencies, reliable distributed operations, and highly available independent deployment, for instance, because it's needed by our quality attributes we just defined. Also, we can say that architecture is language, set of choices, architecture is framework like Togo, for instance, which is quite big and excessive, but helps, to be honest, to define the architecture of the enterprise. Today, I will be mainly focusing on the first part, but the rest of the points, that's also could be part of any other system. Okay, so just looking at the system topology and trying to decide how we can control dependencies. Let's imagine we have such system. We have a lot of microservices or services, whatever it is, which are communicating with each other. And for instance, we need to develop something new. And the problem that we don't have any constraints and boundaries. So we have very subjective decisions. I don't know where to put another service, for instance, in that diagram. We have availability coupling, so we have some chain outages. If we'll be just calling one service, that one will be calling another one. And we can find very interesting things like cyclic dependencies, for instance. But lack of reusability, unfortunately, tough incrementally making changes, very likely we're just doing one change in one thing, and from the whole system, it may destroy something in another place. Architecture control is complicated. The problem that from architecture standpoint, it's a bit tricky how to manage that and making decisions. It makes thinking process more complicated, and also lack of accountability for the end-to-end behavior, because we don't know where the exact business process, where is our value proposition. And the first thing we can do, we can do some definition of layers, like starting defining our system and our services in some layers. For instance, we have domain layers related to our domain. Technically, at that point of time, we're solving the main problem, the essential complexity, like of KYC, for instance, or IML. Infrastructure level, which is generic, reusable by anything in the system, and also products layer, whereas our value proposition is living, and which is part where I would say selling to our customers or solving their problem. And some benefits of that, so we have basic hierarchy, we have layers, so it's a little bit easier to control where to put a new service. We have separation of concerns, we can apply different security things, we can apply different infrastructure things, different non-functional requirements, to be honest. We have reduced coupling, less dependencies, but still a lot. Architecture control simplified, because as architect, I can just say, this is a new domain service. I need to put it in the middle. Now we have specific set of rules and policies how to evolve it. We have visible main end-to-end processes. It tends to think about reusability. Maybe I can take a look at the infrastructure layer, maybe I have this service to reuse, but it's still like a bit of encapsulation here. And the next thing we can apply, we can a little bit improve the stuff. We can just start improving providing subsystems, like finding some domains, which is high cohesion, I would say, in defining them in one subsystem with one entry point as API layer, for instance. In that case, it helps us to improves our encapsulate controllable coupling due to much less dependencies, because you have much less dependencies because you have some abstractions in that way. From the architecture standpoint, much easier to control that, because now we have subsystems, not just a lot of microsystems in that way. Cohesion is much higher in that way. Reusability is higher, because we know that if we have a KYC domain, let's say with 5-10 microservices inside, and whenever we need to build something, we will be going there, and very likely we'll be find much easily what is already built, and we don't need to rebuild it one more time. Explicit accountability for the subsystem's performance, it helps us, to be honest, to just really evolve parts of the big company, big enterprise, and managing performance expectations and introducing SLAs, SLOs, as we usually do as part of the SRE. Okay, and that's just one of the pictures like we may have. So on the bottom layer, we have infrastructure, we have domain areas with some domain macro API. which is, for instance, Uber started to use, I think, 3 years ago maybe, but that's a very basic things from the system theory. They have product layer, this product workflows, some backend from front ends, web applications, and that's our architecture. And whenever I need to introduce a new service, I know the constraints, I know the boundaries, I know where I need to put it and what techniques and policies I should apply. Okay, and also the many thing in fintech, to be honest, requires to do a lot of distributed operations. I need to do company onboarding. It has 15 steps. Or I need to do regular KYC and ML. It has, I would say, 5-10 steps. Or deployment, X to Y steps. And we have to deal with that somehow because it should be reliable. So we need to care about retries, not all the system 100% available. We need to do idempotent operations in that way because we have at least once very likely, exactly once is very complicated to achieve. So, and persistent in the way, like we don't want to execute the same thing if it's already done. We want to do it without process freezes. So we need to track timeouts. We need to do compensations in case of failures. For instance, Stripe is not working right now for some reason. We need to switch it to another provider and just do payment via Square, for instance. And of course, be effective and scalable. And for achieving that, there is such thing, I would say probably is quite famous, as Saga. There are a few definitions, to be honest, one from Chris Richardson on the Microsoft.io and another one from the source of that, the original one by Garcia Molina and Salem in the beginning. It names the long transaction. And to be honest, what is Saga? You're just taking the business process and decomposing this business process on multiple steps, implementing compensation for each step, persisting executed steps, and in case of failure, initiate compensations. The problem with that, compensation is not always possible. If we already, for instance, transferred money and already paid commission, we cannot just roll it back. It's not possible in that way. Compensations are often more expensive and ineffective. Because of that example, for instance, it usually leads to very complicated code, but implementation matters. And what we discovered for us, to solve the problem, a mainly distributed problem, we defined that we can start using some kind of workflow and durable execution. Technically, it does absolutely the same, but it helps us to write code as a workflow. It has with compensations, simple and linear, without any callbacks, without any interruptions, just line by line. Orchestration over choreography, in that case, we have explicit process owner. We don't need to find the way in the choreography who is responsible for the whole process. Usually it's a product manager or, for instance, product owner. We want to have it on the tech side as well. And in case of server failure, you're just starting it on another by skipping all the executed steps and executing the next one, which is helping us to achieve efficient execution that way. And on the market right now, we have few open source solutions for that, Cadence and Temporal. This solution were built by people from Amazon, as I remember from Facebook as well, but Meta in the past. And now we have this open source solution. It will deploy something in your infrastructure. Of course, you have to pass security review, but the main thing that will provide you the way to define this complicated work operations line by line with a durable execution. So if something doesn't work, it will be persisting, you're trying, tracking all the timeouts, and you will be just naturally implementing this orchestration of the whole process. Like in the pipeline, we just have step by step, and we can do that. But just lay some agent, we have it in the business code as well, and quite naturally. Okay, and just going next to high availability part, just want to take a look a bit at this stuff. There are many ways how to achieve that. One of the possible ways is to use in Kubernetes, for instance, rolling update or upgrade strategy, which is, to be honest, related to the canary deployment as well, but canary deployment is a little bit more complicated, requires more work to do. And just quick recap what it is. So let's imagine we have the services, 2 pods and the Kubernetes just running under the one service. We have a database, just persisting some data there. In the rolling update, we're just starting to migrating gradually pod by pod. So we just deploy the service to V2. We're now having the traffic in both of them. And we're replacing of course, we have a database in the backward compatible way right now, or we just need to have it. And after some time, we will be just replacing finally all the pods to the version 2. And of course, after some time, we will be just removing all our backward compatibility fixes or things we just did. And what it requires, technically, for achieving that, it requires a lot of things. First of all, our database migrations must be backward compatible. So V1 services can work with the new database because we just deployed a new version, we just run some migration, and vice versa, of course. We need to have our service stateless, because if we have a persisting session of the user in the memory, and when the new pod will be restarted, we'll be just losing that, and very likely it will be impacting the behavior. So we need to persist it somewhere in distributed cache if it's needed. If not, we can persist in databases if it's needed as well. We also need to have all our APIs contracts must be backward compatible as well. So we need to introduce some static analyzers for our REST, GraphQL, and gRPC APIs, which is just necessary for achieving high availability. API semantics should remain the same. It's not only about the syntax of contracts. We may also change some behavior of the API, and we need to test it somehow. And in this case, only task can help. Let's imagine we have a field in the API and just changing the logic on how it was calculated. It may impact our consumers. All new consumers must be able to help all new messages and message queues, because message queues usually is a stateful approach for communication between services, and we need to understand that as well, because we cannot just retry. We need to be able to read new messages, read old messages from a new service, and vice versa. We should also having non-functional requirements the same, because if our API was working 5 seconds, now it's working 10 seconds or 15 seconds, it may impact our guys on the consumer side who was probably building a report for that, for instance. So we have to bear that in mind, but that's the most complicated part, which is probably possible to define with SLAs and solve it somehow, but that's usually very unpredictable because that's not you are controlling that. It's mainly on the consumer side, but it may break them. And feature flags may help us to control functionality availability. So we can just deploy something hidden by feature flag. That's very useful and quite easy technique, but to be honest, it brings a lot of other complications, and it requires, I would say, a different talk about that, but that may help you to achieve. And policies to resolve backward compatibility situations. And the problem also with that, it's great to work on the production usually, but in the development and test environments, we also want to provide developers the best experience. Imagine we have one environment for testing and we have 25 or 30 developers who are working together there, and they want to test on the environment. They want to deploy their service because for some reason we have requirements for that, maybe a lot of complicated integrations, maybe something like that, and we need to deploy it there and to test it there. And if it happens at the same time for all the developers, we very likely will have an attention. And the idea is we can try to use canary deployment in that way for achieving that problem. The same thing, version 1, and we have 2 developers who are working on the version 1, for instance, and we want to do the same thing. We can just deploy a new service with a new image built by a specific pull request in the pipeline, just replacing one of the pods with a new version and adjusting the routing. Of course, database should be backward compatible, and adjusting the routing on the load balancer and our end-to-end test to run them in pipeline to be able to roll the traffic only to the specific pod in that sense. And for instance, I have 2 services, one for one developer, another for another developer, and they can just do it in the pipeline without breaking the system for those who is just running maybe end test every day, for instance, there. It helps to reduce the cost to not developing and deploying a lot of test environments to achieving isolation, but it requires some things to do. Of course, database must be backward compatible. It requires special routing and requires some tricky logic regarding to external integrations and messaging queues, because we need to do some proper routing when we're reading the message from Kafka, for instance. Okay, and just looking into everyday SRE, just want to talk a bit about what we are having every day, I think in most of the companies, but let's just take a look. So that's the famous phrase, anything that can go wrong will go wrong. That's absolutely standard thing. We cannot just living in the way like everything will be reliable 100%, so we need to change our mindset. But we already talked about many things about observability today, and I'll just quickly recapping what we have. So distributed systems, by design, lacks of visibility. That's essential complexity. We need to solve that somehow. We have 3 pillars of observability. We need to solve them anyway, in some way, just to be able to determine the observability of the system, and in the future building some alerts, useful alerts, logs, metrics, and distributed tracing. And for achieving that, we just need to also have a single format and conventions across all the system to easily get that visible in single place, because we don't want to manage 10 different formats of telemetry, which is sometimes so complicated. And in that sense, we can just use very standard thing as OpenTelemetry. There are many other things on the market you can leverage for that, but OpenTelemetry is just a cross-platform open standard. This is a standard, and there are many implementations on multiple languages, multiple tech stacks you can use for your purpose. And just looking into the diagram, just really in a simple way, we have some services on the left side, .NET service, some service, Java service. And that service will be emitting the traces, metric, and logs in a specific format, even in different format, not OpenTelemetry. On the right side, we have a lot of backends for that. Prometheus, for instance, or Datadog, or Murex for metrics. On traces side, Temper from Grafana Cloud, Jaeger, and many other things. And of course, on the log side. To decoupling the backend and the parts of the left side of our services and decouple the formats and how it should be used, we can utilize such thing as OTel collector, which is open source and can be deployed in any place. The benefits, it can accept data faster than backend. If I'll be sending data to Prometheus, maybe there'll be some issues with that. Increased performance related to batching, we can do more efficient operations. Improved resilience with tries. If, for instance, I would say Tempo is not responding, we can just wait for later and don't have this responsibility on our .NET service, for instance. Easier to control GDPR, PII, and many other things. Complicated from legal, sometimes requires some proper understanding. Just by having data masking and data encryption, we can just have our data encrypted before sending somewhere and decrypting that after that. And OTel collector is a very simple thing. You just have few things in the architecture. So on the left side, you can accept data with receivers in the different formats. It can process the data, transform, doing benches, just everything I just mentioned, and produce data in the other formats like OTLP. For instance, I can say my legacy service is producing metrics in Prometheus, for instance, but I want to transform them to OTLP and using in Datadog, for instance. I can just having the service in the middle, which will be helping me to gradually migrating from another format to a single format in the company. And I can develop additional receivers or exporters. And just other things about what we have to do anyway. So reliable messaging. We need to understand our guarantees we need to achieve. If I will be paying twice, or I will be debiting my customer twice, or I will be not in a reliable way, like for instance, I have no guarantees or on post once, it may impact the business. And in fact, the OKRs, the company results, and just the way to grow. So we need to understand our understanding guarantees. That's essential for building a reliable and stable system. We also need to, as I said, care about the dependency. Network failures and retries are inevitable. We cannot avoid them. We cannot make our network very reliable in that sense. So we need to care about the dependency, understanding at least once, and making our consumers idempotent. And that's a separate talk how to do that. But that's part of our everyday work and what we're including in our designs. Incident management, of course, we need to be mature enough to do all of that and understanding how we're solving the problems and learning from them, being more mature in that problem. We need to do data reconciliation. Many sources are replicating, data may be lost, may be modified, many things may happen. So we have to do something with that. And reconciliation helps, otherwise we'll be having a lot of data discrepancy. People will be asking why we didn't get enough data in our CRM system, or audit will come to you and say we don't have all the transactions in accounting, something goes wrong, and we're getting your license, unfortunately. So we have to, in all the fintech living on the reconciliation today, and we have to automate that. And finally, shift left. We want to think before we're doing something. We're having system design reviews, tech specification, test strategy and plan. So shift left is very important in that sense. It's quite complicated to learn developers to think about problems before they happen, but that requires a special techniques how to achieve it, but it helps to reduce the number of problems in the future if we think about them in the beginning of our software development lifecycle. And just in summary, just finishing my talk. So system topology, way to control dependencies. Yeah, just 30 seconds. Which helps us to, from the architecture standpoint, understand how to grow a system in a reliable way, to not get the millions of dependencies without understanding where the business processes. Distributed operations, because we have to do them reliable. It's necessary for the business to achieving end-to-end behavior. We cannot just relying on the network and saying it will be working with us. So we have to implement something like that. Backward compatibility is necessary for high availability, and that requires a lot of work to do, a lot of changes, a lot of understanding, tasks, contracts, static analyzers, and many other things. And finally, define everyday SRE, understand the practices, how to manage complexity, and how to really build the reliable system and achieving the company results. Yep. So that's it. Thank you. Yep. If any questions, happy to answer.